Bessel function, important concepts and formulas. So Bessel function is the solution to the differential equation, which is x square d2y dx square plus x dy dx plus x square minus p square y equals to 0. So the solution of this equation y is equals to jpx, which is the Bessel function. Bessel function. Now jp is given by jp, which is a function of x, obviously, is given by summation m equals to 0 to infinity x minus 1 power m factorial m plus p plus 1 x by 2 2m plus p. Let me write it properly. jpx equals to m equals to 0 to infinity. So this is the solution. Now if now what will be j minus p? It will be this is also a function of x. Let me write it properly again. J minus p of x is m equals to 0 into infinity minus 1 power m factorial m minus p plus 1 x by 2 2m minus p. So, and if p is integer, then jp and j minus p are linearly independent solutions. If p is not integer, then jp of x would be minus 1 power m jpx. Okay, it would be p. So jpx and j minus px are linearly dependent solutions. The small mistake is that it's minus p here. Yes. Now so j jp of x, which is x by 2, I can write it like this: jp m equals to 0 to infinity minus 1 to the power m factorial m plus p plus 1 x by 2 2m. This is even function for p equals to even, and odd function for p equals to odd. And we can see from this term. Now the generating function using which we can uh, generate jnx or jpx, it would be e to the power x by 2 t minus 1 by t, n equals to minus infinity to plus infinity t power n gen x, or you can say jpx. There's some important relations. First would be ddx of x to the power p jp of x is x to the power p jp of minus 1. Let's prove it. jp, we know it's m 0 minus 1 power m factorial m plus p plus 1 x by 2 power p 2, sorry, 2m plus p. Now let's multiply x to the power p, so we'll get m equals to 0 to infinity minus 1, and we know that n plus 1 gamma is n gamma n, so this will become uh, m plus p plus 1, sorry, m plus p gamma m plus p. Why we are doing this, we'll see that later. So this will be x to the power 2, let's write it like this, 2m plus p x 2m plus 2p. Okay, since I am multiplying it by x to the power p. So now let's do derivative of this xp jp of x. So we'll do derivative of this function. So from this part we'll get 2m plus 2p outside. So 2m plus 2p, m equals to 0 infinity minus 1 power m factorial m plus p 1 by 2m plus p and x 2m plus 2p minus 1, since we have done derivative. So this factor will get cut and we'll be left with 2. So m equals to 0 infinity minus 1 power m factorial, and let's write this like m plus p minus 1 plus 1. Okay, same thing as this one. So since there's a 2 outside, so this will become 2m plus p minus 1, and here it's already 2m plus 2p minus 1, and take x to the power p outside, so it would be x 2m plus 2p minus 1. We have written this same thing in a different way. We just took out x to the power p outside. So if we take this outside the summation, xp will be left with m equals to 0 to infinity minus 1 power m factorial m plus p minus 1 plus 1 x by 2 2m plus p minus 1. Okay, so this this term is basically jp minus 1. So xp jp minus 1. So xp jp is this. Similarly, we can prove that ddx of x minus p jp is x minus p dx minus jp plus 1. Now again, if we just integrate this, we'll get x to the power minus p jp x minus p jp plus 1 integration dx. Again, from this earlier, the last relation, this one, we'll get what, uh, xp jp is integration jp minus 1 dx. Okay, now if we differentiate this equation, this one, let's call it A, then what we get? Then we'll get, uh, let's write it first. ddx xpjp is xpjp minus 1. So if we differentiate this, jp dash plus jp p minus 1 is xp jp minus 1. So it would be jp dash plus jp p by x equals to jp minus 1. So jp dash would be jp minus 1 minus p by x jp. Now again from equation this b, let's call it b, this one. So from b, what we get, similarly we'll get jp dash jp plus 1 plus p by x jp. Okay, so now let's call it c, let's call it d. Now if we uh, if we add this, adding c and d, we get 2jp dash is jp minus 1 minus jp plus 1. If we take this half outside, on the other side we get this. Now if we compare these two equations, okay, if we subtract these two equations, what we will get is that 2p by x jp is equals to jp minus 1 plus jp plus 1. Okay, now some commonly used Bessel function for p equals to half, it would be what, jp j half x is m equals to 0 to infinity minus 1 to m minus power m. This would be m plus 3 by 2, right? Because p plus 1, half plus 1, x by 2, 2 into m plus p, which is half. Now using Bessel function, we know that half plus 1 is half gamma half, and it's 1 by 2 into root pi. Gamma half is root pi, so root pi by 2, right? Now again for if it's 3 by 2, now in general it's this n gamma n. So using this formula, what we'll get is that, now we'll expand this. Okay, we'll expand this one, j half x for m equals to 0, it would be what, minus 1 power 0, it's gamma 3 by 2 x by 2, 2 into 0 plus half, so 1 by, for m equals to 0. It would be what, let's write it in the next line. It would be gamma, what is gamma 3 by 2, it's 1 plus 1, uh, it's half, it's root pi by 2 as written here, so it's root pi into 2. Okay, so x by 2 into to the power half. So plus, for m equals to 1, it would be what, minus 1 1 factorial 1 plus 1 1 plus 3 by 2. Okay, so x by 2 into 2 into 1 plus half. Okay, and so on. So if we do the calculations, what we'll get is that root 2 by pi x sine x j half x. Okay, how did we get sine x? If we keep on expanding, keep on expanding, we'll get the the Taylor series expansion of sine x. So we'll get this. Now similarly we'll get j of minus half of x is root 2 by pi x cos x. Okay, now we can derive this from this using the relation we know. This one is j p is x p j p minus 1. If we put p equals to half, then what we get is that d dx of x half j half is x half j minus half. So if we do derivative of this, d dx x half into 2 by pi x sine x is x half into j minus half. So this will get cancelled and pi sine x will become cos x, and this half will come here, so this will become this j minus half. Okay, now if we want to find for p equals to 3 by 2, we'll use the relation x minus p jp is x minus p jp plus 1. So put p equals to half here. So what we'll get d dx x minus p root 2 by pi x sine x is x minus half j 3 by 2, right? So this is half, right? So we'll get d dx of, take root 2 by pi outside, so we'll get 1 by x sine x minus half j 3 by 2. So we'll be doing the derivative. Okay, so 1 by x cos x plus sine x minus 1 by x square is x minus half j 3 by 2, right? So this will be root 2 by pi x. If we take this is x half, right? Same thing, so this will get cancelled, so x half we can take common outside, and cos x minus sin x by x. Okay, this is x square, right? So 1 by x square uh, minus half is x 3 by 2, 3 by 2, and if we take one x half outside, so only x will be remaining, so j 3 by 2. This is the answer. Take that I made is that there's a minus here, so the minus will be carried over. Uh, there should be a minus, sorry, minus here, so this would be plus, this would be minus. Okay, so j 3 by 2x b root 2 by pi x sin x by x minus cos x. Okay,